Okay, the next one that we have is our surface area of our pyramids and our pyramids and our cones. That's what this should say here. Okay, so these are going to be related as well. Our pyramids and our cones both have one base. Okay, and besides that, they have then pyramid has its triangular lateral faces, and our cones have just one curved surface. But the fact that they have one base puts them in the same category. So our surface area is going to be our total area of faces and curved surfaces again. And we talked about that one yesterday. This is where your pyramids and your cones, they have something a bit different. They have this slant height, okay, which is the height from the vertex that is a perpendicular bisector of a base edge, we'll call it. Okay, and we're going to see a picture of that right now. Okay, you see that this picture here, you have a rectangular pyramid. Okay, it's got this shaded base area that's a rectangle. It's got lateral faces still that are triangles. And it's got this slant height. So the slant height is on the side. So it's on one of the triangles. So it's not down the middle of the shape. It's on one of the triangles. Okay, and our lateral area is still talking about the addition of all of those faces without the base. Our lateral area is going to be L equals 1/2 big P times L. Okay, so 1/2, this is because we're talking about triangle faces. P is, again, your perimeter of that base. And L is your slant height. Okay, and we're still taking that to find the surface area. We're still using, like we were with our prisms and cylinders, we're using the lateral area, and then we're adding the area of the base, which in this case is just going to be big B. So whatever that base is, we're going to add in that area of the base added to our lateral area, which is the area of all of our faces. For our cones, our cones, okay, we see that our base is this, sorry about that, the base is the shaded area. You have your radius of your circle right here, your radius, and then the slant height is still coming down the side of your figure. It'll be perpendicular on that side, but it's still coming down the side. The lateral area for your cone is going to be pi r L. Okay, we're not talking about a full length, so this right here, this pi r is your circumference divided by 2. Okay, we're only talking about half. We're getting rid of it because it comes to that point. And then that L, again, is your slant height. Okay, and then the surface area here, we have surface area equals, still using that, and then the area of your base, which in this case is a circle, so you've got pi r squared. So this is your area of your base, which is just a circle, and again we're using your slant height. Let's look at an example. I find the lateral area of the area and surface area for our regular pyramid. So I know that this formula is P times L. I see that the area of my base is going to be 5 plus 5 plus 5, or the perimeter of my base, which is going to be 20 feet. Okay, so this is going to be 1/2 times 20. I'm giving my slant height as 9. Okay, so this is going to give me 90 feet squared. I'm going to use this value because my surface area is 1/2 PL plus the area of my base, so 90 feet squared plus the area of my base is 5 times 5, which is 25, so plus 25 feet squared. This gives me 115 feet squared for the surface area of this rectangular pyramid or square pyramid. And last one is our cone here. So we've got our slant height here, and then we've got our radius. Okay, so for our cone here, we've got pi RL as our lateral area. So I'm going to keep pi. I see that R is 3 times 8, 24 pi, or if you prefer to solve this out, this is going to give me approximately 75.4 inches squared. Remember, your surface area is your lateral area plus the area of your base. So I've still got, I'm going to use pi, sorry about that, 24 pi plus pi and then 3 squared. So 24 pi plus 9 pi, which gives me 33 pi, or approximately 103.7 inches squared for my area. Okay, so those are the ones for our pyramids and cones.